let's try to solve another Leetcode problem. 2915, length of the longest subsequence that sum to target. So we are giving a array nums, and for this nums, all the numbers going to be positive integers, because this is also really important for us to solve the problem. As we can see, the nums going to be positive integers, and it's going to be more than or equal to 1 and less than or equal to 1000. And also for the target, it is less than or equal to 1000 and more than or equal to 1. And for the target, this is also very important for us to solve the problem. Normally, this is going to be a DP problem. We just need to find some numbers, and we're going to check if the sum of these numbers is going to be 9. So for example, 1, 3, 5, the sum of them is going to be 9, and the length is going to be 3, and this is going to be the longest. So we're going to return 3. So this means for each of the num, we can take it or we cannot take it. Yeah, but for each of the num, we can only do it one time. So this is going to be a 0-1 knapsack problem. So normally for the 0-1 knapsack problem, the easiest way is to use a cas. I mean the DFS with memorization to solve the problem. Yeah. So I'm going to prepare I, and let me do some preparations. Maybe I'm going to prepare a final result. It's going to be DFS from 0. And finally, I'm going to return this result. And let me prepare variable n. It's going to be the length of the nums. And I'm going to call the DFS going to starting from 0. So let's just write the function first, and let's just check what we need to add. Because we need to reach this number to the target, and currently we're going to prepare an initial value. It's going to be 0, and we're going to check this total if it's equal to target or not. So this is for us to check. So if I equal to n, this means it goes out of the array, and we can have a return. So we're going to return 0. So this is just the as case, but we have a condition to check. So if the total equal to the target, so we're going to return this 0. Otherwise, this means we didn't find it, so we're going to return a negative infinity. Because according to the problem, if we cannot find it, we're going to return a negative 1. So this is why I designed it as a negative infinity. Now, what I can do, I can have two decisions. I can take this number. So for example, the first number 1, I can take it or I will not take it. But how can I do that? But I need to choose the maximum of the two cases. So it's going to be I plus 1 with total. So this means I will not take this number. So what about if I take this number? It will still go to the I plus 1 because this is a 0-1 knapsack. Yeah. And what about this total? So the total gonna plus this num. It's gonna be nums I. And how many times? And what is the length of the array? We can use this 1 plus 1. So this means it is the length of the array. Yeah. Because we increase one number, so we're gonna plus 1. Yeah. And let's have a run just to check if it works. Yeah, as you can see, it works for some cases. At least we passed testing 1 and testing 2, but for testing 3 we didn't pass it because we return a null. And this is also reasonable because this result equals to negative infinity. So we want to return this result if this result not equal to a negative infinity. So otherwise, so we're gonna return, according to the question, we're gonna return a negative 1. Yeah. Now let's just run it. Now as you can see, it works. But currently, if we want to submit it, so the time complexity is going to be 1000 times 1000. It's going to be a really big number, especially while we are using the DFS with memorization. Definitely, it will not work. Let's just try. First of all, we have the memory exceeded issues. Maybe we're going to think about clear the cache. So let's just clear the cache. So we're going to use cache clear inside of the Python method. Let's just check if it works. Yeah, so if we cache clear the memory, this means that the memory normally should be okay. But we're going to still have the time limited issues. Yeah, now the memory is okay, but we have the time limited issues. This means we need to do some trimming. I mean, while we are using DFS, it's really easy to code, but we have to be careful if it will cause a time limit exceeded problem. So we have to do some trimming. But where we can trim? So let's just trim a total value. So if this total value is more than the target, definitely it is not possible. So we're going to return a negative infinity. So let's just try this way. Yeah, because all the numbers is positive numbers, that means we can do a little bit of trimming for the problem. Yeah, now as we can see it works, but it is still too slow for us. Yeah, but this is okay. If we were to do further trimming, maybe we were to sort the nums. So let's just sort the nums in decreasing order. So nums.sort and reverse equal to true. So this means, so for example, if the target is 9, but we sorted the numbers, all the numbers are really in decreasing order. This means the numbers may be a 5, 5, 4, 1, but our target is 9. If we choose a number like 5 and 5, it exceeds the capacity of 9. It means it is not possible. So we're gonna return a negative infinity directly. We don't need to search anymore. Otherwise, it's gonna have a time limit exceeded. So this is why we're gonna sort the nums in decreasing order, and this is also a good way of trimming for the DFS problem. Yeah. Now let me just run it and submit it. Yeah, as you can see, it works. It improves the speed a little bit, but it is still very slow. But I think it is okay for this kind of problem. Normally, while we are using the DFS for Python, the case, it's like a dictionary. It's really slow, but it is okay. I think that's all for it for this problem. Thank you for watching. See you next time.